Next example. The equations of line passing through point whose coordinates a, b, c and parallel to x-axis are. So here coordinates of one point on the line are given and line is parallel to x-axis. In the options, equations of lines, they are in Cartesian form. For getting equation of line in Cartesian form, we require coordinates of one point. They are present. But we want direction ratios of line. And here it is given line is parallel to x-axis. Instead of direction ratios, even if we know direction cosines, then also we can write equation of line. If line is passing through point x1, y1, z1 and direction cosines of line are L, M, N, then equation of line is x minus x1 upon L is equal to y minus y1 upon N is equal to z minus z1 upon N. So here x1, y1, z1 are known to us. x1 equal to a, y1 equal to b, z1 equal to c. Now before getting direction cosines of x-axis, let us see what are the direction angles of x-axis. Angles made by a line with positive coordinate axis, they are direction angles of line. Angle made by x-axis with x-axis itself 0. X-axis perpendicular to y-axis, so angle between them 90. X-axis also perpendicular to z-axis, so angle between x-axis and z-axis also 90. So direction angles of x-axis 0, 90, 90. From that we get direction cosines. Cosines of direction angles are direction cosines of a line. For every line, there is only one triplet of direction angles and hence one triplet of direction cosines also. So here direction cosines of x-axis, cos 0, cos 90, cos 90, cos 0, 1, cos 90, 0. So these are the direction cosines of x-axis. For all the parallel lines, direction angles are same, so direction cosines are also same. So here we get L equal to 1, M equal to 0, N equal to 0. Equation of line in Cartesian form. X minus x1 is a divided by L1 equal to y minus y1 b upon m equal to 0. Z minus z1 is c upon n c. So this is same as option C. So here answer is option C. Next example. The line joining the points -2, 1, minus a and a, b, c in the direction of vector 6i plus 2j plus 3k, then values of ABC. So we have to find values of unknowns A, B and C. They are coordinates of one point on the line. So line passing through given 2 points, its direction is same as given vector. As direction same means their direction ratios are same or proportional. Now for the vector we shall find direction ratios. If vector is expressed in terms of unit vectors I, J, K, then coefficients of I, J, K, they are direction ratios of that vector. So direction ratios of vector are 6 to 3. Now direction of vector and direction of line passing through these 2 points same. It means that their direction ratios are same or proportional. So we have to find direction ratios of line. Coordinates of 2 points are given. Difference between corresponding coordinates gives direction ratios. A minus of minus plus B minus C minus plus. So these are the direction ratios of given line. These are direction ratios of vector, and as their direction same, direction ratios they are same. And here we have to find values of A, B, C. So A plus 2 equal to 6. From that we get A equal to 6 minus 2 equal to 4. Now value of A 4, it is given in one option only. But still we cannot say option A is answer because none of these. This is also one of the options. So values of B and C, if they are not same, then answer will be option D. For that we have to find values of B and C also. B minus 1 equal to 2. B equal to 3. Still we have to find value of C. Then only we can decide whether answer is option A or option D. C plus A equal to 3. C. 3 minus 8 minus 5. It means that here answer is option A. Next example. The direction cosines of the line x minus 2 upon 2 is equal to y plus 3 upon minus 2 is equal to z r. In the options, direction cosines are given. Now here equation of line, it is given in Cartesian form. From numerator we get coordinates of point on the given line. Denominator gives us direction ratios of line. Here we have to find direction cosines of given line. So we need only direction ratios, because by using direction ratios we can find direction cosines of line. We don't require coordinates of point on the line. Let us denote direction ratios by ABC. A equal to 2, B equal to minus, C equal to. Z can be written Z upon 1. It means that value of C is 1. Before getting direction cosines, let us find under root A square plus B square plus C square equal to under root. Put the corresponding values. 2 square plus minus 2 square plus 1 square. 4 plus 4, 8 plus 1, 9. Root 9, 3. And here in all the options denominator is 3 only. So even if we don't find its value, it is okay. Then direction cosines, they are given. L equal to A upon under root A square plus B square plus C square. A is 2. So we get 2 by 3. Then M, B upon under root A square plus B square plus C square. Value of B is minus 2. Denominator same. N, C upon under root A square plus B square plus C square. C is 1. Denominator 3. Compare it with the options. Here, answer is option C. Next example. Equation of line passing through given 2 points 0, 0, 0 and 2, 1, minus. So coordinates of 2 points on a line are given and we have to find equation of line in Cartesian form, because every option it contains line in Cartesian form. Now observe the options. In numerator, x minus 0, y minus 0, z minus 0 is present everywhere. Means in numerator this point is used. x1, y1, z1. Now x2 minus x1, 2 minus 0, 0. Similarly we get y2 minus y1, 1 minus 0, that is 1. z2 minus z1, minus 3 minus 0, minus 3. Then equation of line in Cartesian form. X minus x1 is 0 upon x2 minus x1, 2 equal to y minus 0 upon y2 minus y1 is 1 equal to z minus 0 upon z2 minus z1 minus 3. Now compare it with the options. Here we can observe that this is same as option A. Answer is option A.